In this demo, we will focus on one of these apps called Mastodon. Mastodon is a well-known microblogging site that's very similar to Twitter. Since this is an open source app, its source code is available on GitHub. This is a complex app and runs seamlessly on Postgres. This app has grown massively, especially after Twitter went private. It needs to accelerate lift and shift modernization. So let's see how we can migrate this app from Postgres to YugabyteDB. Currently, the Mastodon app is running on the RDS Postgres instance. The application config file shows that the app is connected to the Postgres database. So now, to migrate this app, let's create a YugabyteDB cluster. This is an RF3 cluster with 3 nodes with 16 cores on each node. So the cluster has a total of 48 cores. This is similar to RDS Postgres using M512X large instance with 48 cores. Now, the YugabyteDB cluster is up and running. Let's create a SQL client connection to the YugabyteDB cluster and then create a database named Mastodon in this cluster. Once we connect to the Mastodon database, we can see there are no tables created in this database yet. Let's now create a Mastodon schema. For this, we have the pg_dump file from Postgres and let's apply it to the Yugabyte cluster. It's now creating all the relations. I have created the Mastodon app setup as well using Docker and Nginx. The domain name for this app will be mastodon-yb. The app needs to have a database host and port. So let's provide the Yugabyte database host and port. The app now points to the Yugabyte database. Now, let's check if our Mastodon app is running on mastodon-yb domain. Excellent. You can see the app is up and running. Let's also check the Yugabyte cluster. Here, we can see all the tables and indexes are created now. The local timeline is empty, so let's publish a few tweets to get the load running. We are using a modern workload generator called Locust. It simulates a large number of simultaneous users. So let's generate tweets from 100 concurrent users with a spawn rate of 10. This is awesome. The app is running fine on the Yugabyte database. Now, let's compare the performance of these two apps. On the top, we have the stats from the Mastodon Postgres app, and on the bottom, we have the Mastodon Yugabyte app. Let's look at the average latency stat. You can see better average latency number in the case of Mastodon running on YugabyteDB. But latency is just one aspect of performance. Let's see how this app is doing on the other perf aspects and how it's performing on YugabyteDB versus Postgres. You can look at the request per second or RPS graph. Also, look at the response time graph. This graph captures both the median response time as well as the 95th percentile. With Postgres, the median response time is 690 and the 95th percentile is 800 milliseconds. And the same graph with YugabyteDB, the median response time is 670 and the 95th percentile is 700 milliseconds. So with YugabyteDB, the response time of the app is lower as compared to the same app running on Postgres. Alright, so we showed an app that was running on a single node Postgres instance and migrated it to a modern, scalable and resilient platform without facing any performance issues that would impact customer experiences. It was seamless, just like Postgres, and we can perform such migration for a broad set of different applications.